Hey, all you Gretas and Shootescots out there. Welcome to Unit 1, Section 4 Notes, Water Availability. So let's get started. So once again, in your packet, you should be on the fourth section that says the hydrologic cycle. It's just the fancy word for the water cycle. So water is kind of important. Why? Vital for all life. Everything needs water to survive in some way or another. It helps moderate our climate, which will be addressed multiple times in multiple units this year. It helps sculpt the land. It literally can change how the land is shaped. It removes and dilutes waste and pollutants, so good, fresh, flowing water can actually do a lot to clean up the environment if we leave it alone. And it moves continuously through the hydrologic or water cycle. So it's kind of nifty, and we need it to do so for us to not die and stuff. So here's a really neat picture. If you take all of the water on the planet, it would be about this much, and put it in a big old ball. This is how much room it would take up. This is the amount of fresh water available to us. Amount of fresh water on the planet, and this is the amount of fresh water actually available to us. So in the grand scheme of things, not a lot of water, so we kind of need to take care of it. Click. All right, so we're going to skip to the next page. You've got those nifty little graphics. So here we have distribution of Earth's water. Most of the total global water, which is that first column. The oceans are 96.5%. We have some saline funky things. I don't care that you know that, but freshwater is 2.5%. So most of our water is oceans, a tiny, tiny 2.5%. Sometimes they round it up to 3 for test questions, is freshwater. And then we're going to go on to the second column. And out of freshwater, 68.6% are glaciers and ice caps, 31.1% is groundwater, and only 1.3% is surface water and other fresh water. So out of all of the Earth's water, only about 1.3% can we actually access easily. And that I've definitely seen on test questions in the past. And then, here it is, surface water and other fresh water. So we have our ice and snow is most of that. And then we have lakes, moisture in the soil, swamps and marshes, rivers, water, and atmospheric water. So feel free to pause and write all that down, or just use the PowerPoint that I have uploaded. But I just want you to understand a very, very small percentage of it is stuff that we can actually use. So out of our fresh water, very little of it is usable. There we go. So the little circle on your packet says only about 0.02% of the Earth's water supply is available to us as liquid fresh water. So we need to really take care of that 0.02%. There's a video you can watch and a couple questions on the following page about where the post-apocalyptic water war will be fought. Let's go about some places to go or not to go. Here is the water cycle in all of its awesomeness. Ta-da! All right, flows and throughputs. If you go back a page, it was at the top. You kind of skip that. We skip that. So transfer process, and it's not exact, but so the way that the water cycle does stuff and changes locations, it can infiltrate down through soil. It can run off. So when you see rain going down your street into the sewers, storm drains, that's runoff. Plant uptake is bringing it through the roots. Transpiration is releasing it into the air. Seepage, you can seep water various places. And then precipitation is water stuff coming from the sky. Does not involve consumption or percolating, which is down through the soil. Transformation processes, so how they're going to change. Snow can melt, water can evaporate. Sublimate is going from a liquid, I don't know how to explain this well. Going from a liquid to a gas going from a solid to a gas. So ice actually does this. If you leave ice in your freezer long enough, it goes from that solid and it just kind of evaporates. So technically it sublimates. Water can freeze, water can condense, and then fog can actually drip, which is kind of cool. So the effects that climate change has on water is and this is going to come up a couple times, precipitation will either increase or decrease. So in areas where there's already a lot of rain, there's going to be more, which is going to be us here. In areas where there already isn't a lot of rain, it's going to be even less. So hopefully that makes sense, which means there's going to be more droughts or there's going to be more flooding. We get the flooding, yay! Sea level will rise because water. Loss of ice, habitat, or freshwater sources. So a lot of places get their freshwater from the glacier melt that replenishes every winter. We don't have that as much anymore. And a lot of critters like the ice to live on or near. Polar bears both hunt and reproduce on the ice. So when you don't have ice, we're not going to have polar bears. And then groundwater depletion as well. We're taking water We're taking water out of the ground faster than it is getting replenished. So we should stop. Other human effects, pollution, various chemicals, toxic metals, endocrine disruptors, eutrophication, which means excess nutrients. We'll go more into that later, and thermal pollution, which literally just means the water gets too hot. When water is hot or warms up at all, it contains less oxygen. So all those nifty little fish that live in the water can no longer have something to breathe. So the fish literally suffocate in water because you warmed it up and now there's no more oxygen. And then you have way too many dead fish. Places to find water. Ocean is the largest, obviously. Lakes, rivers, snow, clouds, atmosphere, living things, both plants and animals, and groundwater. So that is the little chart in your notes. So important water vocab is going to be on this next page. So here are the words, and I'm going to go through them. So you don't have to write anything down yet, but these are the words we're going to be addressing next. So going in order, we start with groundwater. Groundwater is precipitation that infiltrates the ground and is stored in soil and rock. Easily, it's water found under the ground. So water is going to infiltrate down through the soil, and it will end up, you've got your soil areas, and then you have this sand and gravel, and the water is underneath you. So the water table is the top. So if you were to go into your backyard and dig down probably just 10, 15 feet, you would hit the water table. Please don't try that without parents' permission first. But the water table here is not that far down. So you could set up a well in your backyard if you really wanted to. But that when you hit that water table, that's your groundwater. All right, surface runoff. Water that does not sink into the ground or evaporate into the air and runs off into bodies of water. So it goes into lakes, it goes into streams. In residential areas, it's going to go into the storm sewers and eventually to a body of water. But that would be surface runoff. Rain runs off. Pretty obvious. Watershed or drainage basin. This is a land area that delivers runoff, sediment, and any dissolved substances to a stream. So it's a bigger area that remember in Nemo when they said all drains lead to the ocean? It's kind of like that for each watershed. All of the rain in a watershed will lead to the same one area, same stream, same main body of water. And I will show you Indiana's in a little bit. An aquifer is an underground cavern and porous layers of sand, gravel, or bedrock through which groundwater flows. So the aquifer is where you can find the groundwater. And I think we go into detail. Yes. So I won't go into detail now, but you have it both an unconfined and a confined aquifer. Stay tuned. Water table is the level below which the ground is saturated with water. So when you dig a big hole in your backyard and you hit water, there's your water table. So in times of drought, that water table is going to drop. In times of a lot of water, the water table can go up. Other things can affect it. There was an earthquake in Alaska and water tables in Florida were affected. So it's kind of cool to see how the earth reacts to things. But you can tell something about what's going on by how high or low the water table is. All right, so with your aquifers, you can have an unconfined or confined. So unconfined is most of them. It has a permeable water table. So what happens is it rains and it's going to infiltrate down and then get into this unconfined aquifer, maybe accessing a lake or wells or whatever. A confined aquifer is bounded both above and below by rock. So the water is confined under pressure. So these are like millions of years old water. And once you have some type of tap into it, it flows. There's one up in Carmel you guys can check out. Ask me in class and I'll tell you where it is. But you can get like true artesian water. If you hear about artesian water, it comes from a confined aquifer. So it's supposed to be like the best water ever. I have not tried it. Kind of want to. But people literally go and they bring something and you can fill it up from this aquifer with nifty water. So some aquifers are replenished by precipitation, others are not, but also you have to remember to not take it out at a rate faster than it is getting replenished, which we're doing a whole lot. Artesian well. Hey, I just talked about this. Pressure from the confined aquifer pushes water up at a location without a pump. So you literally just need to tap this and it will just come up. So usually they have some type of a sealant on there so it's not just flowing. But once you access that confined aquifer, it's just going to keep flowing. It's pretty cool. All right, so how watersheds work. All the rain in this area is going to end here. So it doesn't matter if it rains here or here or here. Anywhere, it's going to end up in this lake. Here is Indiana's watershed. So most of this will end up, most of Indiana, when it rains, it will end up in the Wabash River. Up north, it'll end up in Lake Michigan or the Illinois or the Maumee River. Don't know that one. And then Ohio River down to the south. But most of Indiana is all Wabash River. But that's pretty cool that you can be up here or down here and it rains and it all ends up in the same river. More diagrams. So you can look at these later. Ooh, I'm not going to walk you through all of this, but understand the main concepts of how the water cycle works and interacts. If you have questions about what any of these words mean, please comment below or ask me in class. But if you comment or email me, then I can put it in the comments and then everyone can get an answer to your question. Another one. They even have definitions down here for you. So we're getting hotter and wetter conditions in the northeastern coasts, and we're having hotter and drier conditions in the interior west. So with climate change and the using up of too much water, the heat trapped by the atmosphere causes more evaporation and therefore more precipitation, but we're going to have less here and more here. Once again, areas that already get some rain, like we do, are going to get more, so that's more flooding. That means farmers are going to have to push back a lot when they plant, and so we're going to have crop issues, and then they're going to have massively drier areas and then have droughts and other issues with that. So other effects of climate change. How does climate change affect the water cycle? So all of these things. But once again, you're going to have more or less precipitation. So areas that already get rain are going to have flooding. Areas that don't get rain are going to have more droughts. You're going to, because of that, have increased irrigation and uptake required in those drought areas, which is going to cause a lot more groundwater to be lost and depleted aquifers. It will also cause a decrease in both land and sea ice because it's warmer, which will cause the sea levels to rise. So not good. Oh, it doesn't even give you a chance. So on the next page, don't look at that, guys. On the next page, go ahead and pause this and attempt to answer the questions on the next page, and then unpause it and check your answers. So pause. Did you really pause? You should have paused. Okay, now I'm going to show you the answers. Here's your practice question. So there are the answers. I won't read them for you because you know the letters of the alphabet. If you have questions about why any of them are what they are, please feel free to, once again, ask me questions, email me, or comment on this video, and then I can answer them for everybody. But look at the little kitties. They're so cute. All right, you guys have survived. So I would like to take this opportunity to tell each and every one of you that you are good enough, you are smart enough, and that people like you. And if in case I don't see you, have a good afternoon, have a good evening, and good God, do your homework.